I'm from Embed, and what I'm going to talk about is systems engineering to help overcome component supply issues. I don't know if anyone knows, bit of a secret, there's a little bit of a component supply issue going around. It's hard to get chips, it's hard to get components, it's hard to get anything. It's an absolute pain, and it's causing us and our customers a lot of headache. So as time's gone on, we've developed some techniques and some activities that have really helped us. So I'm just going to share those. But first off, I've got a couple of slides about Embed. I wouldn't be doing my job if I didn't mention a little bit about us, what we do, and what we offer before I dive into a little bit more. So, yep, we're automotive systems engineering focusing on embedded systems, software, in electronics, the smaller items of things, not infotainment, a lot of bare metal code, a lot of bare metal electronics design and software design. We work with very, very many companies. Some of the newer ones out there, Rivian, VinFast, Canoe, as well as some of the old players, Panasonic, Jaguar Land Rover, Bentley, etc. We've worked with many people over the years. 17 years we've been going, and over 40 staff. Some wonderful marketing stuff that we had some marketers come and talk to us, and they noticed we always make tea in a teapot. It's just something we do. Someone goes along, puts the kettle on, fills the teapot with a pot of tea, rings a bell to let everybody in the office know there's a pot of tea, and we make our tea that way. And one of the marketers sort of said, well, do you do everything right? We do everything right. We focus on process, we focus on testing, and we do everything properly, including that first brew of a morning. And hence our little teapot logo. We're based in Coventry. This is my doorstep, thank goodness. I've done conferences all over the place. It's lovely to have one 15 minutes away. So we're based in Coventry. Myself and my colleague, Derek, lead. I'm in charge of commercial. He's in charge of technical. But April this year, we were acquired by Littelfuse. We've won a Queen's Award. That's another wonderful thing that we're extremely proud about. That was export. We developed 8 ECUs for Rivian. So 8 of our ECUs are on Rivian vehicles. That was a big project. That was fantastic. We got it a short while before COVID, and as a business, Rivian were not needing to sell vehicles to be profitable. And very, very many automotive companies struggled a lot during COVID, mainly because they were reliant on selling vehicles. If you can't sell vehicles, you don't get money in. Thank goodness that big project was fantastic for us. Technically very interesting, as well as helping us win a Queen's Award. This is what we do. We develop some of our own products. We design hardware, software, application software, and of course we're a consultancy business, and we look at ISO 26262 projects and the like. We've worked to automotive spice and so on. So that's what we're about, Embed. But what I'm going to talk about today, we can't buy a component. What are we going to do? What on earth are we going to do? Well, we can panic. Everyone panics. First thing you do, as soon as you can't find a component, you get that horrible feeling. It's, what shall I do? Can I source them? Can I go out on the market and pay crazy prices for them? Massive, massive percent increases. But what you can do, well, whoop, I'm going the wrong way. Switch the process. So I'm going to run through several different techniques and several different things we've done to try and help us overcome the component supply issues. So switch the process is one thing we do, and it's something we've started about 12 months ago. And one of the main problems is, we're finding this. We were turning up at Avnet or wherever saying, I want to buy something that they just don't sell. They haven't got it. It doesn't matter. It isn't happening. You turn up, you can't buy it. So this is our process that we used to work to, and I'm sure some of you work to this now. You come up with your requirements. What I/O, what type of speed you want, the flash, you design something, schematics, layout, software, and you go to build it and buy some components, send it down a line and get it made. You can't build it, so back round to design, and then back round to trying to build it. And you get stuck in this loop, and you can get stuck in this loop for months. And we have, to start off with, that's where we were. That's exactly where we were, and it was turning into an absolute pain, really dragging projects out. So what we do now, we get our requirements, and then we buy it. We identify components before we've laid out a board, before we've designed the schematics, before we've done a thing. We buy components, we put them on the shelf. And as a design consultancy, I don't know where your businesses are and what you do. We go over to the OEM, the tier one, and sort of say, I need a war chest. Give me £100,000, and then I'll buy the stuff. I'll protect your business. I'll reduce the risk for your business going forward. And I will buy the items. And I've got to say, a colleague, Steve here, has been fantastic at helping us overcome these issues. But this is something we do. We get a war chest from our customers to buy components, and then we start the design. It really, really, really does help a lot of the types of issues you continuously get. Of course, sometimes you buy something that's not right. But you can always sell it back into the market. At the moment, the risk is very, very small for buying something wrong. It's easy enough to sell it. As long as you've not opened up your seal pack, you're okay. Systems design. This is something else that you can do to try and help. Well, change the focus. Absolutely change the focus. You've got to make flexible, portable code. Chip replacements, you've got to be part of the design. Expect manufacturing a number of variants. I think one of the gentlemen, it was the guy from McLaren Applied, was it Josh, the supply chap? He was saying expect to make many, many variants, lots of little changes, continuous little changes, as opposed to a big, we're doing a new version now. Expect to make a variant with a different chip, a variant with a different driver, a variant. Expect it, design it in, plan it, make sure you've got enough space on your board, try and layer the design to make it possible. Is it possible to have several different pad designs in the one area so you can accommodate different types of H-bridge driver, funny ASIC, PMIC, etc. What can you do to try and protect that and make it more resilient to the problems you are going to face? And also, one of the upsides is it might enable you to bring in new technology as well. So not only does it protect against risk, it might also enable you to bring in some new technology later on. Hi there. Thanks for coming. Layering. This is another technique that we do, and I'm sure it's nothing overly new, but it's something that we've just turned the volume up on. Absolutely turned the volume up on layering. So, layered portable code. Layered portable code. Code's only portable if you don't break the layers. So we've seen many, many different problems where people have, in the application, inadvertently called something at the low level. Obviously, you should never, never do it. Layer your code as much as possible. And even in the layer, as well as logic between. So this low-level driver, as much as possible, if you're changing the lower layer, you only change the lower interface. If the upper layer changes, you only change the upper interface. So each case, what can you do to split out and protect as much as possible from other aspects? And this goes all the way through the system. Here's an example sort of software call chain to try and explain some of it. So if you imagine an ECU, the innermost code, as it were, is the application. And that application is looking at the outermost part of the vehicle. Then as you get Lower down in the code, that's looking at the closer and closer and closer parts. So at the very seat tilt down, at the very high level, you've got some logic about driving a seat and how to, when should it tilt, when shouldn't it tilt, and the logic around that. Then you might get a motor manager that decides what the motor's going to do. Then that motor manager will pass down to a lower layer, a H-bridge driver. And that H-bridge driver will even go down to a lower level to call the SPI driver. So if you need to change the microcontroller, you'll probably need to change your SPI driver. But it shouldn't change your H-bridge driver, it shouldn't change your motor manager, it shouldn't change your application. You've got to protect those layers as much as possible. Likewise, if you've got your H-bridge driver and you're changing the H-bridge on the chip, if your microcontroller's not changed, you shouldn't have to change your SPI driver. It should be very, very clean layers. You'll have to change your H-bridge driver. And typical, in the main picture, this is your microcontroller abstraction layer, your MCAL. This starts going up into your ECUAL, and here's your application input-output processing, your motor manager, and at the top's your actual application, what the customer wants it to do at the high level. Hardware can be layered too, where possible. I'm not a hardware engineer, but the more you can protect one bit from the next with a generic interface of any type, the more likely you are to be able to overcome changes in the design that are forced on you by supply issues. I almost collared that ST gentleman earlier because we've got a supply issue with ST, but I think everybody has a supply issue with every supplier. It's not just ST, they're a good bunch. But we've got some problems. So we've got a microcontroller, we've got some type of serial interface. Hopefully you can change your H-bridge driver, your P-link, or other types of items without too much trouble. You'll have to change your driver code, but not your SPI code in your micro, but you should be able to change your chips on the board. And it should also, if you've given yourself space on the board to enable that to happen, it gives you the opportunity to be a bit more flexible when you start getting issues. Model-based software development. Now this is another fantastic way to try and protect yourself from changes in the system. So application developed in the model can be used to generate code, compiled for any microcontroller. So it enables you to be a lot more flexible. You can target wildly different architectures. You can even get coders for VHDL in MATLAB Simulink, so you can go into a hardware solution. But the more you can work with a model-based development, typically the more portable your code is. It enables you to test it within the model, within the simulated environment, and then do some hardware-in-the-loop testing, software-in-the-loop testing, and then target your particular board that you've chosen. Testing too. It's always worth having a golden sample of whatever it is. Always have a golden sample, then your new whatever it is, your new variant, your new function, test it against that, back to back against that. As many layers as possible in the testing as well. Lots of test points on the board. Can you isolate what it is you've changed to ensure that the inputs and outputs you're sending to it and from it are the same as before, and automate it as absolutely much as possible. I've just seen the Vector guys step in. We've invested in some VT test suites from the good old Vector chaps to automate it as much as possible. You're going to test a lot more than you ever did before as the variants change, as you're continuously changing your board. Automate it. You'll need to do more than you thought. So, I don't know if there's any questions, but they're all my sort of hints and tips for how we can best protect ourselves from the ever-changing or the ever-changing boards that we're going to have to design as we get problems with supply chain.